Hi, Assalamualaikum and a very good morning. So now we're going to do some tutorial discussion for chapter 8 and we're going to focus on the subtopic of 8.3 which is preparation of alcohol and 8.4 chemical properties of alcohol. So we're going to do tutorial question 5, tutorial question 6, 7, 9 and 10 respectively. So without any further ado, let us start. So for tutorial question 5, we have to write the complete equation for each of the following reaction. So for B, we have 2-propanol heated with a concentrated H2SO4. So propanol, it will have 3 carbon and at carbon number 2, it's going to be attached with OH. And then this is going to be heated with the concentrated H2SO4 at high temperature. Okay, so here refers to a reaction that is being heated. So what concentrated H2SO4 do to this compound here is that it's gonna undergo the dehydration processes. Means that it's gonna remove water. Okay, so OH gonna be removed from this side, and in this case, it can remove water from this area or in this at this carbon here. So either one of that doesn't matter. So let's say if I choose this hydrogen here, so OH and H gonna be removed as the byproduct. So we're gonna plus H2O, and as a result of the removal of water, double bond gonna be forming here. Okay. Now for 5C, we have 2-methyl 1-propanol heated with acidified K2CR2O7. So propanol, we're gonna have 1, 2, and 3, and then at carbon number 1, it's going to be attached with OH. So it's going to be 1-propanol. And at carbon number 2 here, it's going to be attaching with a methyl group. So when it is heated with the K2CR2O7, which is an oxidizing agent, strong oxidizing agent, and applied under heat. So what it's going to do is that the primary alcohol here, so this carbon here is a primary alcohol. So when having a strong oxidizing agent, the primary alcohol gonna be oxidized into carboxylic acid as the product here. Okay, so as a result, this carbon gonna be a carbon oxygen double bond, and then OH gonna be attached here because oxygen the agent here is a strong oxidizing agent, so gonna become a carboxylic acid. Okay. Now we have 1,2-ethanediol, which reacted with potassium. So ethane gonna have 2 carbon, 1 and 2, and then at carbon number 1, it's gonna be attaching with OH, and at carbon number 2, it's gonna be attaching with OH. So this is known as 1,2-ethanediol. Okay, and then it's gonna react with potassium. So potassium metal gonna be labeled as K. But now we're gonna put it as 2K because it has 2 OH group here. Okay, and as a result, the potassium gonna remove the hydrogen, and this gonna produce O minus and K plus here. Okay, and the same goes to this side here. Okay, and the byproduct, which is the hydrogen, gonna be removed, and hydrogen gonna be removed, gonna be labeled as hydrogen gas. Okay, plus two potassium reacted, and it's gonna produce O minus and K plus here. Same goes on both sides, and the hydrogen gas here. Okay, and then for 5E, we have the glacial ethanoic acid, which is heated with 2-propanol in the presence of the concentrated H2SO4. So glacial here doesn't really affect much on the reaction. So glacial here refers to a dry ethanoic acid or without water. So it is purely an acid, which is ethanoic acid. So ethanoic acid will have 1 and 2. Okay, 1 and 2, 1 and 2 carbon, and then one of the carbon going to be attached with carboxyl group, and then this going to be reacted with the 2-propanol. So propanol will have 1, 2, and 3. And then at carbon number 2, it's going to be attached with OH here. Okay, and these going to be reacted together in the presence of H2SO4. Okay, so let us draw the structure again. So first we have the ethanoic acid plus 2-propanol, and then with the presence of the concentrated H2SO4 at high temperature because it is heated, so what we're going to get is an ester. Okay, and the use of the concentrated H2SO4 here going to be acting as a acidic catalyst. Okay, and in order to produce ester, the OH group here going to be removed, and the H here and the H here going to be removed. So hydrogen from the alcohol going to be removed, and OH from the carboxylic acid going to be taken out in order to produce water. Okay, and as a result, the O can be bonded into this side here. So if we were to do that, okay, the product going to be here. So if we were to do that, we will get O like this, okay, and then it going to be attached with the carboxylic part. Okay, so it's going to look something like this as for the ester. Okay, remove the OH and remove the H, and then oxygen can be bonded to this part here. Okay, so which is this one. Okay, so we're going to produce our ester as shown here, and then our byproduct going to be water. Okay, so if we were asked to write the name of the ester, we can do the naming based on the reactant that were given. So first we have the ethanoic acid, and here we have 2-propanol. So if we want to do the naming for an ester, we're going to start with alcohol first. Okay, so remember AC. A first, then only carboxylic acid. So alcohol here going to be propyl, okay, because all we change into YL. So 2-propyl, ethanoic acid, OIC, we change it into OATE. So it's going to be ethanoate. Okay, so the name going to be 2-propyl ethanoate, and the byproduct going to be water. Remember, the concentrated H2SO4 going to act as a catalyst. Okay, right. So now let us do the last question here for this slide, which is 1-hexanol will react with the PCC in the presence of inert solvent, which is the dichloromethane. Okay, so for the hexanol, we have 1, 2, 3, 4, 5, and 6. And at carbon number 1, it's going to be attached with OH. Okay, and PCC here going to act as the mild oxidizing agent. Oxidizing agent yang tidak kuat, yang sederhana saja ataupun lemah. Okay, so when this 1-hexanol here is known as a primary alcohol. Okay, so when primary alcohol react with a mild oxidizing agent, we're going to form an aldehyde. Okay, so at the end, what you're going to get is double bond O and hydrogen on this side here, which is an aldehyde. Okay, so the name going to be hexaldehyde. So let us do the structure nicely, which is 1-hexanol react with PCC, which is a mild oxidizing agent, and then we're going to do the arrow as well as the solvent, which is the dichloromethane, and what we're going to get is the hexaldehyde, which is an aldehyde. Okay, so let me rub off here so that you can see it clearly. Okay, now we're going to proceed with the same question, which is question 5, but the new letter, which is the cyclopentanol, react with SOCl2 in pyridine. So SOCl2 here is known as the thionyl chloride. So you need to know the name here because sometime in exam they will straight away ask you to react with thionyl chloride. So you need to know the structure here, which is SOCl2. So cyclopentanol is a cyclopentane and attached with OH group. Okay, when it react with SOCl2, this must happen with the solvent of pyridine. Okay, so what happened here was the OH gonna be substituted with a Cl. Okay, and this gonna produce a byproduct of the sulfur dioxide as well as the hydrochloric acid. For I, we're gonna react 1-bromo 1-methyl cyclopentane. So we have our cyclopentane here, which is 5 carbon, 1-bromo and 1-methyl. Okay, so this is our 1-bromo 1-methyl cyclopentane, and then when we react it with the aqueous potassium hydroxide, which is KOH, the Br gonna be replaced with OH here. Okay, so this is according to the SN1 mechanism, which is the nucleophilic substitution reaction. Okay, so OH gonna replace the Br, and you can also write the byproduct if you want, which is the byproduct here gonna be the KBr. Now we're gonna we're gonna do question number L, which is CH3-MgBr. So you know that it is acting as a Grignard reagent. So when there is MgBr, automatically it reminds you about Grignard reagent. And this gonna react with a propanol, which has a formula of CH3, C double bond O, CH3. Okay, so this is a ketone. Okay, so when Grignard reagent react with a ketone, you know that you're going to produce a tertiary alcohol. Okay, so what you're going to do is that the CH3 going to be attaching here, and the carbon double bond oxygen going to be OH. Okay, it's going to be single bond and OH here. So you're going to produce a tertiary alcohol, which is C double bond O here, and then it's going to be attached with 3 alkyl group. Okay. Now we're going to do the last question of question 5, which is the cyclohexene, which is the structure like this, and then it's going to react with a strong oxidizing agent at acidified condition. So there must be H plus here. So when it add up with the KMnO4, which is the strong oxidizing agent, and H plus here, what it's going to do is it's going to oxidize the alkene here, and it's gonna have a producing a carboxylic acid. Okay, so ikatan carbon-carbon double bond akan diputuskan. So this relates back to the chapter of alkene. Okay, so we have 1, 2, 3, 4, 5, 6 carbon. Okay, so you imagine it as a getah gelang. Okay, so when it is being cleaved, bila dia diputuskan, dia akan jadi satu rangkaian yang panjang. So what you're going to do is that you're going to draw six straight carbon chain, which is 1, 2, 3, 4, 5, and 6. Check again, which is 1, 2, 3, 4, 5, 6. Okay, and at carbon number 1, it's going to produce a carboxyl group. Okay, and same goes to the carbon number 6 here, which is a carboxyl group. Okay, so this is the product of the reaction. Okay, so you can draw it this way, or you can also draw it in terms of the condensed structure here, which is 1, 2, 3, 4, 5, 6. Okay, the number of carbon is still consistent, and then we're gonna make it as the carboxylic acid at both ends. Alright. Now for tutorial question 6, we have to show the preparation of propanol from 2-bromopropane. So bromopropane gonna look something like this, which is propane have 3 carbon, and at carbon number 2 it's gonna be attached with bromine, and then you're gonna produce propanone. So 3 carbon, and then it's gonna be attached with double bond O. Okay, because this is a carbonyl, and then it's gonna attach with carbon and carbon, so it's gonna be ketone. Like this, it is known as aldehyde because it is attached with hydrogen. So if both attached with carbon, then it is known as ketone, which is the propanone. Alright, so now we're gonna produce propanone from the 2-bromopropane. So what we're gonna do is that it is not necessarily one step. So it can consist of 2 steps in order to get to our product here. So let us draw the structure again, which is 2-bromopropane. So first what I can do is that maybe I can make it as a secondary alcohol first, where I'm gonna replace my Br with OH. Okay, so I'm gonna use NaOH aqueous, and then I'm gonna oxidize my secondary alcohol into ketone. Okay, so this is the steps in order to get to the product. So it consists of 2 steps. Step yang pertama dan step yang kedua. Okay, so let me draw it nicely here, which is the 2-bromopropane, and then I'm going to use NaOH aqueous, and then it's going to undergo nucleophilic substitution reaction, where the Br going to be replaced with OH, and then I'm going to oxidize it with KMnO4 at acidified condition at high temperature, and this is going to produce a ketone. Okay. Now I'm going to proceed with question 6b. So first I'm going to have 1,2-dibromoethane. So ethane, at carbon number 1 I'm going to have bromine, and at carbon number 2 I'm going to have bromine as well. So they asked me from ethanol. So ethanol going to have 2 carbon, 1 and 2, and then at carbon number doesn't matter which one, they're going to have OH here. So ethanol to produce 1,2-dibromoethane, which is on this side here. Okay, so in order for me to synthesize this product, what I'm going to do is that first I'm going to dehydrate it, so undergo dehydration so that I can get my alkene, and from my alkene I'm going to react it with the bromine in CH2Cl2, which is in a solvent of dichloroethane, so that Br can attach that side, and Br can also be attaching on the other side. Okay, so let me draw it nicely on this side. So first we have the ethanol, and then as mentioned I'm going to go with the dehydration. So I'm going to use the concentrated H2SO4, and then this is going to produce me an alkene. So attach with hydrogen, attach with hydrogen, attach with hydrogen, and attach with hydrogen. Okay, so now I'm gonna put Br on both sides. So logically, I need to put my Br as the reactant. Okay, so add with Br in the dichloromethane, and this is gonna produce my product here, which is 1,2-dibromoethane. Okay. Okay, so for the synthesis, you can also write it as Br2CH2Cl2. Okay, so if you don't want to use this way, you can also put it this way, only for the question of preparation. Okay, for other question, you have to write the reactant on the left hand side. For example, concentrated H2SO4. Okay, similar to those in the question number 5. So you need to put your reactant as a plus sign. Okay, the exception is only applied for the um, synthesis question or the preparation question. Okay, so that you can put the thing on the top if you want. Okay, but if you don't want to pening kepala, so you can just use plus um, the plus method here so that it is consistent with the others. Okay, so for tutorial question 7, we have to give a chemical test in order to distinguish between 2-methyl 1-propanol and 2-methyl 2-propanol. Okay, so as you know that for the chemical test, either you are using Lucas test or ionoform test in order to know whether it is a primary alcohol or secondary alcohol, and so on and so forth. Okay, so the first thing first, the best way that you can do at it is to draw the structure. So for propanol, it's going to have 1, 2, 3 carbon, and then the OH going to be attached at carbon number 1. Okay, and at carbon number 2, it's going to be attaching with methyl. So this one is 2-methyl 1-propanol, and if I were to draw 2-methyl 2-propanol, I'm going to get something like this. Okay, so this one is this one, and this one is this one. So what differentiates between those two is that it is a different classes of alcohol. So this alcohol here, which is the carbon attached to the hydrogen, attached to the OH group, gonna be attaching with one big alkyl group. Okay, so it's gonna be a primary alcohol. Okay, because this one is H and this one is H. But for this one, this carbon here gonna be a tertiary alcohol. Okay, so we can use Lucas test in order to differentiate both of the alcohol here. Okay, because Lucas test is going to give a positive result for a tertiary alcohol. Alright, but for the primary alcohol, the cloudy solution will not be formed even after 10 minutes at room temperature. So we're going to draw the structure again, where we're going to use Lucas reagent, which is we are using the zinc chloride as well as the HCl. So please use a comma instead of a stroke. I make a mistake there. And then I'm going to draw the structure of 2-methyl 1-propanol again. And then the 2-methyl 1-propanol going to react with the zinc chloride in the presence of the HCl. So for this case, because it is a primary alcohol, the chlorine atom could not replace the OH. So we can say that there is no observable changes. Okay, please don't write no reaction, because for identification test, we are looking for the observation. So we need to write no observable changes. Okay, so we can say that no cloudy solution formed even after 10 minutes at room temperature as for the observation. Okay, meanwhile, for 2-methyl 2-propanol, which is this one is 2-methyl 2-propanol. So when we react it with the zinc chloride using HCl, what we're going to do is that the OH going to be replaced with chlorine. So this is the formation of the alkyl halides, and you are going to see a two-layer. Okay, so one layer is cloudy and one layer is clear, as what you have learned in the lecture and what you're going to see in the laboratory. So what you're going to say is that the cloudy solution going to be formed immediately. And as the byproduct, the hydrogen going to be attaching with OH, so it's going to be producing a water. Okay, so similar case for B, which is benzene and cyclohexanol. So here is benzene, and cyclohexanol going to be something like this. Okay, so here it is not an alcohol, which is it is a benzene, but here is a secondary alcohol. So for the chemical test, we can use Lucas test again, because Lucas test gonna replace OH with Cl. But for benzene, there gonna be no observable changes. So we can use Lucas reagent, which is zinc chloride with HCl, and then benzene when reacted with zinc chloride at acidified condition, there gonna be no observable changes. So you can say that there's no cloudy solution formed even after 10 minutes at room temperature. And here we have a cyclohexanol, which is a secondary alcohol, the carbon here. And then it's gonna react with the zinc chloride with HCl, and this OH gonna be replaced with Cl here. So we can say that the cloudy solution form within 5 minutes. Okay, for tertiary alcohol, it's gonna take immediately. Okay, so tertiary alcohol, the cloudy solution will be immediately. Secondary alcohol within 5 to 10 minutes. For primary alcohol or no alcohol, not an alcohol, it's gonna no cloudy solution is formed. Okay, now we're gonna do question 7C, which is 3-pentanol and 2-butanol. So both are alcohol. So in order to understand it more, let us look into the drawing first. So if I were to draw 3-pentanol, so I'm going to get 1, 2, 3, 4, 5 carbon, and then it's going to be attached with OH at carbon number 3. For 2-butanol, I'm going to get 1, 2, 3, 4, and at carbon number 2, it's going to be attached with OH. Okay, and as what you can see here, this carbon here going to be a secondary carbon, secondary alcohol, sorry. And here, the carbon that is attached with OH going to be a secondary alcohol as well. Okay, because if you were to expand, you're going to get C here going to be attached with 1 and 2 alkyl group. Same goes to here. You're going to get 1 and 2 alkyl group. Okay, so both are secondary alcohol. So you cannot use Lucas test. What you can do is you can use the iodoform test. Okay, so iodoform test gonna be used in order to detect methyl carbinol group. So it's gonna be attached, the carbon gonna be attached with OH, CH3, and H here. So here can be any other stuff. So when there is this kind of structure in the molecule, then we can use the iodoform test. So if you were to look at here, which is this structure here, C attached with OH, attached with H, but now attached with ethyl. So it is not the same because we need a methyl here. Okay, but for here we have C, OH, H, and CH3. So we know that this is the same as this one. So it is known as the methyl alcohol group, or known as a methyl carbinol group. Okay, so when there is a presence of this kind of group, when we are using iodoform test, it's going to give a positive result, which is the formation of the iodoform, which is a yellow precipitate. So let us do it nicely. So when we react our 3-pentanol, so here is 3-pentanol, with using iodoform test, we're going to react our iodine in the presence of NaOH. But for the identification test, there are going to be no observable changes. So you can say that there is no yellow precipitate that is formed. However, for 2-butanol, it has the methyl carbinol group, which is COH, CH, CH3. Okay, so it's the same as this one. So when we're going to react that with iodine in the presence of NaOH, what we're going to produce is the carboxylate ion, which is this one, and it's going to reduce by 1 carbon chain. And then because of the negative charge, our metal of sodium going to be closely related to closely together with the carboxylate ion. Okay, so one negative and the metal going to be positive charge. Okay, so initially it got 1, 2, 3, 4 carbon chain, but now it become 1, 2, 3. And the CH3 here going to be used to react with the iodine, which is the CHI3 here. Okay, and this structure is known as the iodoform or known as the triiodomethane. Okay, so iodoform, and that is why you use iodine. So this color of the precipitate is known as the yellow precipitate. Okay, so for tutorial question 9, compound P is an alcohol. Upon oxidation with acidified KMnO4 solution, a ketone Q is formed. P, which is an alcohol just now, will react with PbR3 to give R, which is then purified and refluxed in dry ether along with the magnesium metal to form a Grignard reagent S. S is then treated with Q followed by acidic hydrolysis to yield 3,4-dimethyl 3-hexanol. We need to identify P, Q, R, and S, and we have to write all the equation for the reaction involved. Okay, so kalau kita baca macam ni, confirm tak faham. So what we're going to do is we're going to lay out the idea one by one. So what I'm going to do now is I'm going to do like a flow chart so that you can understand it better. So idea, so we know that compound P is an alcohol. So you write it, compound P is an alcohol. Upon oxidation with acidified KMnO4 solution, a ketone Q is formed. So P, I will undergo oxidation with the KMnO4 in the presence of acid, which is H+, in order to form ketone Q. Okay, so this is the first sentence here. Okay, and then P reacts with PbR3 to give R. Okay, so P will react with PbR3 to give R. Okay, and as you know that when alcohol will react with PbR3, the OH group going to be replaced with Br. So I know that R going to be a haloalkane. Okay, so that until the sentence here. And then R will then be purified and refluxed in dry ether along with the magnesium metal to form a Grignard reagent S. Okay, so haloalkane tadi dia akan react dengan magnesium. So nampak je magnesium, confirm Grignard reagent. So we're gonna plus with magnesium and dry ether in order to form a Grignard reagent which is labeled as S. Okay, and then S is treated with Q. Okay, S akan direaktkan dengan Q yang kita dah hasilkan tadi. Followed by acidic hydrolysis. So S, we're going to react with Q, followed by the acidic hydrolysis. So this is step number 1, and then this one is step number 2, in order to yield 3,4-dimethyl 3-hexanol. Okay, and this is our product, the last sentence here. So then we need to identify P, Q, R, and S. Okay, so for this part, we have to draw the product first, and then we're going to do the reverse way. Kita patah balik ke belakang, because we know that the product here is given as 3,4-dimethyl 3-hexanol. Okay, so it's going to have 6 carbon chain. Okay, which is 1, 2, 3, 4, 5, 6. And at carbon number 3, they're going to be attaching with OH. And then at carbon number 3 and 4, it's going to be a methyl group. Okay, so we know that this is our product. And then we need to identify Q. So we know that our product here is a tertiary alcohol because the carbon is attached with 1, 2, and 3 alkyl group. So you know that when Grignard reagent react with something will give you a tertiary alcohol. So the something here going to be Q, where Q here you know that it is a ketone. Okay, as what you have learned, if Grignard reagent react with a methanol, it's going to give you a primary alcohol. If Grignard reagent, so this one is methanol, if it's react with aldehyde, okay, one is CH3 and the other one is H, it's gonna give you a secondary alcohol. But now, if it is a ketone, it's gonna give you a tertiary alcohol. So you know that the answer for Q is definitely a ketone. Okay? And from here, you need to deduce the structure of Q. Okay? Kamu kena bayangkan apakah Q tersebut. So the best thing to do that is I'm going to look into this part here. Okay? The one that contain the OH group. So I know that the Grignard reagent, my ketone, will have the double bond just now. When it react with the Grignard reagent, it will become OH. So I know that if I'm going to go the reverse way, the OH here going to become the double bond. So I have 1, 2, 3, and 4. Okay, so I'm going to have 1, 2, 3, and 4. And then at carbon number 2, I'm going to have double bond here, which is carbon double bond with oxygen. So this is going to be my Q because I'm deducing it from here. Okay, and the balance here, which is going to be my Grignard reagent. Okay, so I know that my structure of Q going to be looking like this. Okay, so 1, 2, 3, 4. So this is my Q. Okay, when I know my Q, I can also put it here again. Okay, and from here, I can predict that my alcohol going to be consistent to my ketone. So my alcohol going to be OH here. Because when a secondary alcohol is being oxidized, I'm going to get a ketone. Okay, and from here, it's going to be easy to deduce the structure. So from an alcohol, when it react with PBr3, the OH going to be substituted with Br. So I'm going to get the structure of like this. So this is going to be known as the 2-bromobutane. Okay. And now, my haloalkane here going to react with the Grignard reagent. We're going to react with magnesium in dry ether in order to produce Grignard reagent. So magnesium going to be inserted at MgBr at Br here in order to form MgBr. Okay, so I'm going to write it that way. And my Grignard reagent here going to react with Q in order to produce this product as shown as a 3,4 dimethyl hexanol. Okay, so here you can further. Okay, so when this one react with this one, what you're gonna get is OH here, and then MgBr gonna be attaching here, where MgBr gonna be lost. Okay, so it's gonna be something like this. Okay, so here is my 1, 2, 3, 4 carbon. So it's gonna be 1, 2, 3, 4, which is consistent. And then here 1, 2, 3, 4 is up here 1, 2, 3, 4. And then it's gonna make a bond in between them. So if I were to count again, I will get 1, 2, 3, 4, 5, 6. Okay. So at carbon number 3, it's going to be attaching with methyl group and OH. At carbon number 4, it's going to be attached with a methyl group. So if you were to look at this structure, it is the same as this structure here. 1, 2, 3, 3 got OH, got methyl group. 3 got OH and got methyl group. And at carbon number 4, they got methyl. Okay, they got methyl. And at carbon number 5 and 6, it's going to be consistent. So it may look ugly here, but essentially it is the same. So it just wanted to show you that it is a consistent product if you were to prove that. Okay, so this is the idea. So I think for any kind of reaction, you need to have the flow chart or like a diagram in order to help you to understand the situation. Okay. Now we're going to use the idea that we have made, and then we're going to use that to write the equation nicely one by one. Okay, So first we have our alcohol. So when our alcohol react with PBr3, we're going to produce R, which is haloalkane. So OH going to be replaced with Br. So this one is the first mark here. And then we're going to use our R, where we write it again. And then we're going to add up with our magnesium metal, which is plus sign here. And then in the condition of dry ether and reflux. So what we're going to produce is S, which is the Grignard reagent. So do not forget to label each and every one of the structure that you have drawn. Okay, and from the Grignard reagent, we're going to react with our structure Q, which is our ketone that we have determined, and this going to give our product, which is a 3,4-dimethyl-3-hexanol, and this happens at the acidified condition, okay, which is here. So this one is step number 1, and then this one is step number 2. Okay, and at the same time, Pu can be converted into Q, P can be converted into Q by oxidation with the strong oxidizing agent. So P plus KMnO4 under reflux, with acidified condition, it's going to produce a ketone, which is ketone Q here. Alright, so this is how you answer the question regarding the complex information here. So remember to come up with an idea first, and then you can draw it nicely one by one in order to get a full mark. Alright, now for tutorial question 10, an alcohol which is C4H10O which has several isomers give the following observation. So isomer L will give a negative result with Lucas reagent. So when L give a negative result to Lucas reagent, we know that it is a primary alcohol. And it forms butanoic acid when oxidized with acidified potassium dichromate solution. So logically, primary alcohol, when oxidized, it's gonna form a butanoic acid. So I know that it is confirmed a primary alcohol. Okay, so isomer L is a primary alcohol because it gives negative result with Lucas reagent, and it forms carboxylic acid when oxidized with acidified K2Cr2O7, which is a strong oxidizing agent. Okay, now you know that it is a primary alcohol and it has 4 carbon. So logically, you're going to do 1, 2, 3, and 4. Okay, and then on the last carbon here, going to be OH. So if you were to count the number of carbon, it's going to be 4 carbon. If you complete your structure, H3, H2, H2, and H2 here, so what I'm get is 6 plus 1, 7 plus 3, 10. H10 O. So I know that it is consistent. So I know that L gonna be my structure here. Okay, which is butanol. Okay, so I'm gonna draw the structure and also label. So label is important. Okay, and this gonna react with a Lucas reagent. So you know that Lucas reagent consists of the zinc chloride and the concentrated HCl. Okay, so you're gonna react with zinc chloride with HCl, and this gonna give no observable changes. Remember, do not write no reaction. Okay, because we are talking about the identification test, we need to look at the observation. So we need to write no observable changes, and for the observation, there's gonna be no cloudy solution formed after 10 minutes at room temperature. Okay, at the same time, we're going to draw the structure again for the 1-butanol, and then we're going to react that with the K2Cr2O7, which is a strong oxidizing agent under acidified condition, and then you're going to see that a butanoic acid is formed. 1, 2, 3, 4. So butanoic acid. Okay, so you know that the color of the dichromate is orange, but when it is oxidized, the orange solution is going to turn green. Okay, now we're going to do number 2 here, which is isomer M is optically active and give positive result with the iodine NaOH aqueous. So you know that this is known as the iodoform test. where the iodoform test is used to detect the methyl carbonyl group. Okay, so it need to be in the form of this structure, where this refers to methyl carbinol or methyl alcohol. Okay, and it needs to be optically active, means that it needs to be chiral molecule. So if you look into here, it is attached with 4 different groups. So R here need to be different than CH3. Okay, so I know that I need to have 4 carbon, which is 1, 2, 3, and 4. So here gonna be my OH, here gonna be my H, and then here gonna be my CH3, and then here gonna be my carbon. And this gonna be my ethyl, which is CH2 and CH3. And this gonna be my chiral molecule. So if I were to draw it this way, it's gonna give a positive result for the iodoform test because it have a methyl carbonyl group, and it is chiral because it is attached with 4 different groups. Okay, so isomer M is optically active because it has a chirality center here, and it gives positive result towards iodoform test due to the presence of the methyl alcohol or methyl carbinol as I mentioned here. So we're going to draw the structure again, which is like this, and then you need to label it with M, and then when you react it with the iodine using NaOH aqueous, what you're going to get is the carboxylate ion, and it's going to carry a negative charge, and your sodium metal going to carry a positive charge, and it needs to be nearby. And as a result, the triiodomethane or iodoform going to be produced. Okay, so your triiodomethane or iodoform going to be produced, and this going to give the observation of the yellow precipitate. Okay, now we're gonna do number 10(3), where we are still using the same isomer, which is C4H10O, and we know that isomer N react instantly with the Lucas reagent. So when it react instantly with Lucas reagent, you know that it is a tertiary alcohol. And then it does not decolorize acidified potassium solution of the potassium dichromate. So you know that it is a tertiary alcohol because tertiary alcohol have no hydrogen to be oxidized. Okay, so it cannot be oxidized. So it confirmed that isomer N is a tertiary alcohol. And okay, so logically you will draw it as, because you know it has 4 carbon, right? So it's going to be 1, 2, 3, CH3, 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 OH. So you know that it's going to be a tertiary alcohol. And then the formula going to be C4, H9 plus 1, H10, and oxygen. So it is consistent to the question. Okay, so you know that it's going to have this structure here. Okay, so you can draw it in terms of the expanded here or condensed here, or you can do it in terms of the skeletal structure. So for structure N, it's going to react instantly because it is a tertiary alcohol, and then it's going to react with zinc chloride using HCl as the acid, and this is going to produce a haloalkene. At the same time, it will causes the solution to turn cloudy immediately because it is a very favorable process for the tertiary alcohol to do the nucleophilic substitution reaction. Okay, and at the same time, the isomer N will not be able to react with the K2Cr2O7, which is a strong oxidizing agent, and at acidified condition, we say that it is no observable changes. So the purple color, oh sorry, this one is not purple, the orange solution of the chromate ion will remains unchanged. Okay, because Tertiary alcohol cannot be oxidized because it does not have hydrogen at the carbon. Okay, so I think that's all for today's video. See you again some other time. Bye.